Hello guys! In this video, we are going to discuss binomial probability distribution. So for today's lesson, we are going to define binomial experiment, illustrate binomial probability distribution, find the exact probability for X successes in N trials of a binomial experiment, and solve problems involving binomial probability distributions. So let us define binomial experiment. So a binomial experiment is a probability experiment that satisfies the following four requirements. Number one, there must be a fixed number of trials. Number two, each trial can only have two outcomes or outcomes that can be reduced to two. These outcomes can be considered as either success or failure. So that's why it is called binomial experiment, because it has two possible outcomes which are considered success and failure. Number three, the outcomes of each trial must be independent of one another. And number four, the probability of success must remain the same for each trial. Okay, so here are the examples of binomial experiment. Number one, selecting 20 students from a university and recording their sex. So it is a binomial experiment since there are two possible outcomes, male and female. And another one, the trials or the number of trials is fixed, 20. Okay. So if you check it, so the four requirements are satisfied. Number two, selecting 5 students from a large school and asking them if they are on the dean's list. Why is it considered as a binomial experiment? Because there are two possible outcomes. The student is in the dean's list or not in the dean's list. Okay, number three, surveying 100 people to determine if they like Sudsy soap. So, like, yung isa, dislike or do not like. And last one, tossing a coin 100 times to see how many heads occur. So, fix yung number of trials, 100 times. Then, there are two possible outcomes, head and tail. And what? The outcomes are independent with each other. So, if the first trial is head, so the second trial does not depend on the result of the first trial. Okay, kaya siya independent. So, the outcomes of a binomial experiment and the corresponding probabilities of these outcomes are called binomial distribution. So, binomial distribution is a special type of discrete probability distribution. So, in addition, the following are the notations for the binomial distribution. The first is P of S, which is the probability of success, P of F, the probability of failure, P, the numerical probability of success, Q, the numerical probability of failure. In short, P of S is equal to P, and P of F is what? The complement of P, which is 1 minus P. And 1 minus P is denoted by Q. Okay, so most of the time we will use P and Q for the probability of success and failure respectively. N is the number of trials, and X is the number of successes in N trials. Note that X must be greater than or equal to 0, but less than or equal to N. And X are integers 0, 1, 2, 3 up to N. So how we are going to compute binomial probability distribution? So binomial probability formula. So in a binomial experiment, the probability of exactly X successes in N trials is P of X equals the combination of N taken x times p raised to x times q raised to n minus x. So in this lesson, we are going to recall combination. So what is again combination? Okay, to solve binomial probability distribution problem, it is necessary that you are familiar with combination. So, combination, the number of combinations of our objects selected from n objects is denoted by combination of n taken r and is given by the formula combination of n taken r equals n factorial divided by quantity n minus r factorial times r factorial. Remember that combination of n taken r is the same as combination of n taken r at a time. So this NCR is the key in your calculator. So same lang sila. So say for example, what's the combination of 4 taken 2? So ibig sabihin, same din lang yan siya sa 4C2. Okay. So it is equal to 4 factorial divided by quantity 4 minus 2 factorial divided by 2 factorial, which is equal to 4 factorial over 4 minus 2 is 2. So 2 factorial times 2 factorial. And we know that 4 factorial is 4 times 3 times 2. And so on. So 2 factorial na yon. Divided by, so 2 factorial is equal to 2 times 1 times 2 factorial. So we can now cancel 2 factorial. So we have 4 times 3, 12 divided by 2 equals 6. So let us have the first example. Suppose that in a certain university, it is known that 20% of students shift to another degree program after 1 year in their initial program. In a random sample of 15 freshman students at the university, find the probability that exactly 8 students shift to another degree program. So first, identify natin yung mga given. So what is our n? Ang n natin is the number of possible trials. So we have 15. What is our x? Number of success. 8. Exactly 8 students. And then yung probability of success natin is 20%, which is equal to 0.20. And yung q is the complement of p, which is 1 minus 0.20, which is equal to 0.80. So again, our formula is the probability is okay. The probability of x, which is equal to combination of n taken x times p raised to x times q raised to n minus x. So substitute lang natin. Probability of x equals 8. So you have 15 combination of 8. Our p is 0.20 times x raised to x, which is 8, times 0.80, okay, raised to 15 minus 8. So we have 15 combination of 8 times 0.20 raised to 8 times 0.80 raised to 7. So use your calculator to find the value of the expression. So we have 15 combination of 8 times 0.20 raised to 8 times 0.80 raised to 7 equals 3.45 times 10 to the negative 3, or in decimals 0.00345. So this is the probability of getting exactly 8 students that will shift to another degree program. Okay, problem number 2. The probability that a patient recovers from a rare blood disease is 0.4. 15 people are known to have contracted this disease. What is the probability that letter A, at least 10 survive, and letter B, from 3 to 8 survive? So, let us first solve letter A. So, letter A is asking for the probability that at least 10 survive. It means that x is greater than or equal to 10. So how we are going to solve for the probability that x is greater than or equal to 10? So let us first identify the given. Ang n natin is equal to 15. Our probability of success is P 0.4. And probability of failure, yung Q natin is 1 minus 0.4, which is equal to 0.6. So, probability of x greater than or equal to 10 is the same as probability of x equals 10 plus probability of x equals 11 plus probability of x equals 12 plus probability of x equals 13 plus probability of x equals 14 plus probability of x equals 15. So, isa-substitute lang natin yan dun sa ating formula. Like sa first example, 1 by 1. So, if x is equal to 10, so we have 15 taken 10 times p, so 0.4 raised to x, which is 10 times 1 minus 0.4. So, yun yung ating 0.6. So, 15 minus 10, 5. So, if x is 11, so we have 15 taken 11. So, same pattern lang. So, 0.4 times 11 times 0.6. 15 minus 11, 4. Plus, if x equals 12, so 15 taken 12 times 0.4 raised to 12 times 0.6. 15 minus 12, 3. X equals 13, so 15 taken 13 times 0.4 raised to 13 times 0.6. 15 minus 13, 2. Plus, x is 14, so 15 taken 14 times 0.4 raised to 14 times 0.6. 15 minus 14 raised to 1 plus 15 taken 15 times 0.4 raised to 15 times 0.6. 15 minus 15, 0. So, using your calculator, you input all of this directly, your probability of x greater than or equal to 10 is equal to 0.0338. Okay, so the probability that at least 10 survive is 0.0338. Okay, let us solve letter B. Probability that from 3 to 8 survive. So what does it mean? It means that we have to find the probability that x is greater than or equal to 3 but less than or equal to 8, which is the same as probability of x equals 3 plus probability of x equals 4 plus probability of x equals 5 plus probability of x equals 6 plus probability of x equals 7 plus probability of x equals 8. Then using the same given, substitute lang natin. So we have 15 taken 3 times 0.4 raised to 3 times 0.6, 15 minus 3, 12, plus 15 taken 4 times 0.4 raised to 4 times 0.6 raised to 11, plus 15 taken 5 times 0.4 raised to 5 times 0.6, 15 minus 5, 10, plus 15 taken 6 times 0.4 raised to 6 times 0.6 raised to 9, plus 15 taken 7 times 0.4 raised to 7 times 0.6 raised to 8, plus 15 taken 8 times 0.4, so 0.4 raised to 8 times 0.6 raised to 7. So as you can see, when you add the exponent, always 15 yun. So using your calculator, probability that x is greater than or equal to 3 but less than or equal to 8 is approximately equal to 0.8778. So this is the probability that from 3 to 8 survive.